Welcome back, Geometry Scholars. Today's lesson is on midsegments of triangles. The essential question continues to be, how do triangle properties assist in solving real-world problems? The lesson objective is that you'll be able to construct midsegments in triangles and use the midsegment theorem to solve problems about triangle side lengths. Don't forget to utilize the questions margin in your Cornell notes to write questions for me, or questions, because sometimes these questions are actually answered later on in the Cornell notes. Let's go ahead and get started. The midsegment of a triangle is a line segment that connects the midpoints of two sides of the triangle, and every triangle has three midsegments. Now in this example, they've only noted one, they've noted DE, but actually every triangle has three of them. The triangle midsegment theorem states that the segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is half of that side. So looking at this example of triangle ABC, triangle ABC is noted. DE is the midsegment, and I know that D is the midpoint because DB is congruent to DA. I also know that E is the midpoint because BE is congruent to CE. So DE is parallel to AC, and I also know that because they've marked the parallel lines. And so we can find the measure of DE or AC as long as we have the other one, because DE is half of AC, or if you don't like working with halves and fractions, you could say that AC is 2 of DE. So you're going to either double or half, whatever your preference is. Example 1 we're going to come back to at the end. In example 1 we're proving that the midsegment theorem actually does work, but what we are going to do instead is we're going to skip example 1. You're just going to trust that it does work, and at the end we'll talk about why it does work. So let's go to example 2. Use triangle RST to find UW and the measure of angle SVU. U is the midpoint of RS, so this is congruent to that. V is the midpoint of TS, so that is congruent to that. And W is the midpoint of RT. 1, 2, 3, 1, 2, 3. So since we know that those are the midpoints, we also know that UV, right here, is one of the midsegments, okay? And UV is parallel to RT, since UV is bisecting RS and ST. The other side it's not touching is RT, so that's the one it's parallel to. And then, I'm going to use another color marker, UW is parallel to ST. UW is the midsegment, it's halfway between RS and RT, so it's the midsegment of a triangle as well, and so UW is parallel to ST. So we can find UW because looking back at our notes, we know that the midsegment is half of the line it's parallel to. So you need to divide 10.2 in half. So divided by 2, and your answer is 5.1. So UW is 5.1. I cut 10.2 in half because the midsegment was parallel to ST, which was 10.2. Now, since we're working with the midsegment theorem, and I'm going to go and erase what we have on the board just so we can look at the triangle a little bit better. Nothing's clouding it. Since we're working with the midsegment theorem, we're working with a triangle that has some parallel lines built in it. So they want us to find the measure of angle SVU. So we're looking for this angle right here. Well, I know that this line and this line are parallel. We just said that they were parallel when we were at the beginning, and I even marked it right here. UW is parallel to ST. And so this dotted line that I'm drawing, that I'm extending, is a transversal, and it's cutting that it's intersecting those parallel lines. So this angle that we're looking for and the angle that we know, what kind of angles are those? Well, they're alternate interior angles. And from our knowledge, we should know that alternate interior angles are congruent. So the measure of angle SVU is also 41 degrees because they are alternate interior angles. And we haven't really done a lot with parallel lines inside of triangles, but with midsegment, since we have parallel lines, we will be. Let's try another problem. Example 3. A surveyor needs to measure the distance PQ across the lake. Beginning at point S, she locates the midpoints of SQ and SP at M and N. So I always mark up my image, and that's something that you should be in the habit of also, is marking up your image using the information that they tell you. She then measures NM. What is PQ? So we already know that NM is the midsegment. We know it's the midsegment because it said that N is a midpoint and M is a midpoint. So since this is a midsegment, it's half of this. So NM is half of PQ. Well, I also showed you at the beginning that maybe you don't want to divide in half, or maybe sometimes it's easier just to multiply instead. We can also say that PQ is double 2 times NM. So the longer one is 2 times the shorter one, or the shorter one is half of the longer one. Well, this time we know the shorter one, so using the doubling method actually would work easier. So PQ equals 2 times 78. So PQ equals 156. And I'm looking back, we're measuring, and sure enough, they have the units, 156 meters. Okay, this is very much more basic than what we've honestly been learning the past couple of lessons. Very easy as long as you just remember that the midsegment is half of the parallel side. Let's try example 4. Find x. So I know that this line right here is the midsegment because this midpoint cut this side in half, and this midpoint cut that side in half. Okay, so 3x, the midsegment, is equal to 1/2 of the long segment, 4x plus 20. Or again, if you do not want to use a fraction, which it's easy to use a fraction here because 2 goes into 4 easily and 2 goes into 20 easily, you could have written it as 4x plus 20, the longer one, equals 2 times the smaller one. Okay. Either one would have worked. I'm going to go ahead and show you the longer way just so we can have some practice with dividing by fractions. But 3x equals what's 4 divided by 2? 2x. And then what's 20 divided by 2? 10. So 3x equals 2x plus 10. Going to subtract 2x from both sides to get x by itself. X equals 10. Voila, there we are. It would have worked out the same if we would have done it the opposite way. 4x plus 20 equals 6x. I would have subtracted 4x from both sides. Would have gotten 20 equals 2x. Divide by 2, and x would have still been 10. Okay, so either way you work it out, it's going to work out. You can divide by 2 or you can multiply by 2, whatever your preference is. Either way is the right answer. Example 5. In triangle QRS, points T, U, and B are midpoints. So I'm going to go to mark that. T is a midpoint, U is a midpoint, and B is a midpoint. How does the perimeter of QRS compare to that of triangle TUB? Well, let's look at what we already know. Can we find any triangle right away? Well, they don't give us the 3 sides of the inner or the outer quite yet. I know that QS is 50 and SR is 40. So I'm going to look next. TB is a midsegment and it's parallel to QR. So if TB is 30, how much is QR going to be? Well, it's going to be double. So it's going to be 60. So 40 plus 50 plus 60 is 150. So triangle QRS is 150. Now I'm going to use green to mark the other triangle. We have 30 already for that segment. So this segment is parallel to this line, which that whole line is 40. So what is TU? Well, it's half, 20. And then I'll mark it in red. This line is parallel to that line. Well, that whole line is 50. So what is the midsegment? 25. So triangle TUB is 20 plus 25 plus 30, which is 75. So how do they compare? How does the perimeter of QRS compare to that of triangle TUB? Say triangle, the perimeter, I'm going to do P, the perimeter of triangle TUB is half the size of the perimeter of triangle QRS. Or you could say the opposite. You could have said the perimeter of triangle QRS is 2 times the perimeter of triangle TUB. Okay, I just used the midsegment. I'm going to cut in half or I'm going to double, and that's what you're going to be doing a lot when you are working with midsegment, is cutting in half or doubling. Okay? Okay, finding the perimeter of triangle TOE. Same exact thing we're doing here. We're going to be using, we're looking for the small triangle right here. This inside one. I noticed that O is a midpoint, E is a midpoint, and T is a midpoint, so we're dealing with all these 3 midsegments. Okay? I can tell they're midpoints by how the triangle is marked up. Okay? So OE is going to now be half of FS. Now, if this side is 6, that side is 6, so 12. What's half of 12? Well, it's 6. And then we have TE is half of FR. Well, that side 12 and that side's 12 is 24, but half of 24 is 12. You notice I'm just using, I'm in a, whatever one side is, that's what we're actually going to be using. And then this last side, OT, is half the length of RS. Well, the whole side is 8, so half of it is 4. So the perimeter is 4 plus 6 plus 12. 4 plus 6 is 10 plus 12 is 22. So the perimeter of triangle TOE is 22. Okay, lastly, we're going to go back to example 1. And this is where we have to prove, where we are proving that this graph actually, that this theorem actually works. So the vertices of LMN are at 2, 7, 10, 9, and 8, 1. They're already there for us. P is the midpoint of LM, and Q is the midpoint of MN. Show that PQ is parallel to LN, and PQ is half of LN, and we have to sketch PQ. So a lot of things we have to do. First of all, they want us to prove that PQ is parallel to LN. So, and we have to sketch PQ, and we have to show that PQ is half of LN. So 3 things we have to do. So the first thing we have to do is sketch PQ. It says it's the midpoint of LM and MN. So if I'm looking for the midpoint of LM, I'm going to use the midpoint formula. So midpoint formula is x1 plus x2 divided by 2, and y1 plus y2 also divided by 2. So I'm looking for LM first. So I'm going to be dealing with L, which is 2, 7, and M, which is 10, 9. Okay? So 2 plus 10 divided by 2, and then 7 plus 9 divided by 2. 2 plus 10 is 12, divided by 2 is 6. 7 plus 9 is 16, divided by 2 is 8. So the midpoint of LM is at 6, 8. So 6, 8, it should be right on the line, and if it's not, then we did something wrong. And sure enough, it is. Okay, so that's my first midpoint. That was my midpoint of LM. I'm going to erase this so we don't get confused. I'm going to go and erase, and we're going to now find the midpoint of MN. Actually, let me mark that this is point P. I said it was P was the midpoint of LM. So I'm going to erase. Again, midpoint formula is x1 plus x2, and this time I'm going to be using MN. So I don't need LM, instead I need M and N. So the midpoint is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. Okay, so 10 plus 8 divided by 2, comma, 9 plus 1 divided by 2. 10 plus 8 is 18 divided by 2, which is 9. And 9 plus 1 is 10 divided by 2, which is 5. So 9, 5 is my midpoint of NM. 9, 5. There we go. So I have my two midpoints, and now I can draw my midsegment. So I've done the first thing. I've sketched PQ. You can mark that off the list. So then we have to prove that PQ is parallel to LN. Well, how do we prove that two lines are parallel? What do they have to have? What do two lines have to prove that they're parallel? Think about it. To prove that lines are parallel, they have to have the same slope. So parallel lines have the same slope. So let's look first at the slope of LN. Okay, so I'm actually going to start, I see that they are going toward the left. They're going, so to go rise over 1, I'm going to start here at N. They're going up 1 over 1, up 1 over 1, up 1 to the left, up 1 to the left, up 1 to the left. So it's going up 1 and then to the left 1. So the slope is -1. So now let's see what the slope of PQ is. Well, starting at Q, up 1 over 1, up 1 over 1, up 1 over 1. Same thing. And if you drew it nice and straight on the line like I should have, you would get 1 over -1 as well, with a slope of -1. A little bit harder on the smartboard getting it perfect, but on your paper you should be able to get it right on those grid lines. So do they have the same slope? Yes, they do. Are they parallel? Yes, they are. So we have proven that as well. And at the end, we will, actually what we'll do is right here on the margin, we will go ahead and write that. PQ, so in some blank space or over the margin, you can write this, is parallel to LN because both lines have slope of -1. They have the same slope. Okay, the last thing we have to do is prove that PQ is half of LN. So I'll redraw it. I just want to get all the extra markings off. So our point was right here and right here. Okay, I need to prove that PQ is half of LN. And the way that we're going to do this is either the distance formula. You can find the distance of PQ and LN, which I know you all love, or we can use the Pythagorean theorem because we have an image that we're looking at. If we didn't have an image that we were looking at, we'd have to use the distance formula. But since we have an image, I can use the Pythagorean theorem. So PQ is technically the hypotenuse of that triangle. Pythagorean theorem says that a squared plus b squared equals c squared. And remember that the c is always the hypotenuse. Well, these sides are 3 by 3. So 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. Take the square root of both sides. Okay, so the square root of 18 is the same thing. We're going to factor out any perfect squares of 9 times 2 equals the square root of c squared. The square root of 9 is 3, so 3 square root of 2 equals c. I can't make that any smaller. So I'm going to write over here 3 square root of 2. Can't make that any smaller unless you were to put it into a decimal. But besides that, and I think if it's a decimal, it's around 4.24, 4.25, something like that. So now we're going to find the length of Ln, also using the Pythagorean theorem. And it's 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5, 6 by 6. Okay, I'm going to erase what we already have. So a squared plus b squared equals c squared. So 6 squared plus 6 squared equals c squared. 36 plus 36 equals c squared. 72 equals c squared. Now I need to factor out any perfect squares. So underneath, oh, I'm sorry, actually I need to take the square root of 72 first, my apologies, and then factor out any perfect squares. So the 36 times 2, because 36 is a perfect square, equals the square root of c squared. The square root of 36 is 6, so 6 square root of 2 equals c. So this was 6 square root of 2, and that was Ln, and PQ is 3 square root of 2. So let's think about this. I'm going to erase what we have right here and see if we can prove that PQ is half of Ln. 3 square root of 2 is half of 6 square root of 2. 3 square root of 2, what is half of 6? Or what's 6 divided by 2? It's 3. So if I work it out, it's right. So is PQ half of Ln? Yes, it is. So we would say PQ is half of Ln, comma, because 3 square root of 2 is half of 6 square root of 2. There's my answer. And as I told you at the beginning, this was a long problem. We had to find the midpoints. We had to then show that they were parallel, and now we had to find the length of the sides to prove it. Okay, so 3 things, but now you can see that indeed it's true. When I find the midpoint and draw the midsegment, that midsegment is parallel to the bottom side, and that midsegment is half the length of the bottom side as well. That's the point of what we just did, to prove that the midsegment indeed is parallel, because we just proved it was parallel, and we just proved that it was indeed half of the base of the triangle, okay, or the third side, I should say. If you have any questions, make sure you write them in your summary or a recap of what you've learned as well, and I'll see you next class.